Standard deviation, written and presented by me, Sean McGuire. Here's legal stuff. Firstly, averages. Average allows us to summarize large amounts of data to get an overall value. Here's an example of 11 people and their ages. And there are three types of average. There's the mean, the mode, and the median. With this data here, I find the mean is 27, the mode is 21, and the median is 25. Here's another set of data, 11 more people, and when I find the mean, mode, and median of this data, they're the same. The mean is 27, the mode is 21, and the median is 25. Now when you look at these two sets of data, you can clearly see that the second set is much more spread out than the first set. The ages range from 5 to 59, whereas in the first set the ages range from 21 to 52. So the second set is more spread out, but they both have the same averages. We need another value which will give us an indication of the spread in the data. The first option is to look at the deviation from the mean. So what I've done is, for each value, I've subtracted the mean from it to get how much it deviates from the mean. And then maybe what I can do is find the average deviation from the mean. That'll give me a value for spread. The problem is that to find the average, I have to add all the numbers together and divide by 11, which is the number of people. And when I add all the numbers together, when I add all the deviations together, it comes to 0, because there's as many negatives as there are positives. So finding the average deviation from the mean is not going to work for me, because of the negatives there. To solve this problem, what I'll do is I'll standardize the values. I'll make them all positive. The easiest way of making them all positive is just to square them, because a negative times a negative becomes a positive. So I'll square all of those deviations, I'll standardize them. And then I'll find the average of the standardized deviations. So I'll add all the standardized deviations together and find the average of that. The last thing I'll have to do is undo the fact that I've squared them. So to undo the fact that I squared them, I square root the whole lot. So I end up with this equation that says my spread, which I'm going to give the symbol sigma, spread equals the square root of the average of the standardized deviation, or the square root of the sum of x minus x bar, which is the mean, squared, or those squared divided by n, which is the number of values. That's my equation I end up with. Sigma equals square root of sum of x minus x bar squared over n. In this case, the sum is 768. And so my sigma, my standard deviation, is 768 over 11, or 8.3. I'll do the other one. I'll do the other set of data. And when I do the other set of data, I find deviation from the mean. I standardize it in each case. I add all the standardized deviations together, and then find the average of those, and then I square root to give me my sigma, my standard deviation value. And in this case, the sum is 3340, and so the spread is 17.4. Now, when I look at my two sets of data, and I put my standard deviations down, you can see that one of them is 8.3 and one of them is 17.4. What this is telling me is that the second set of data is much more spread out. It has a bigger standard deviation. It has more of a spread of values. So this is standard deviation, and we call it sigma. So what? Well, within plus or minus 1 sigma of the mean, we should see 68.3% of all values. Within 2 sigma of the mean, we should see 95.4% of all values. Within 3 sigma, we should see 99.7%. And within 4 sigma, we should see virtually all of the values, which should be within plus or minus 4 sigma of the mean.